Hi, we are looking at question 34, coordinating with the trigonometry final exam review. We're being asked to plot the given polar coordinate and also transform the given point to a rectangular coordinate. All right, so the first thing we want to do is go ahead and plot this point. All right, so I'm looking at my polar grid. And let me grab the point that we're given, which is the point 2, negative pi fourths. And so the first thing I always like to do when I'm trying to plot a polar coordinate is to recognize what quadrant that my angle is going to be in. The first thing I notice is that I have a negative sign here, which is telling me that we're moving in the clockwise direction. And then I also notice, of course, that negative pi fourths, if we took and multiplied that by 180 over pi, we would get that that's negative 45 degrees. So that way we can look at it in both degrees and radians. So I recognize right here, kind of at my halfway mark, is my negative pi fourths, again moving correctly in the clockwise direction. And then what the 2 is representing is the r. So this is our r theta for our polar coordinates. And so since the 2 is positive, we're going to move directly onto our dotted out negative pi fourths here, and we're going to count 2 circles out. So let's see, that would be 1 circle, so I actually want to count 1, and then 2 circles out would put my point right here. So this is the point 2, negative pi fourths. All right, the next thing that I would like to move on, we're going to go back and let's take a look. The second part is they are asking us to transform the given point to a rectangular coordinate. And so to do that, we're going to use our 2 equations. We know x is equal to r cosine theta, and we know y is equal to r sine theta. And that's going to allow us to get our xy coordinate. And so I'll start with my x coordinate first, again noting that this is r and this is theta. I'm going to plug in 2. Then I would have cosine of negative pi fourths. Again, we've already talked about the fact that this is negative 45 degrees. So, of course, using a reference angle of 45 and notating that we are in quadrant 4, we know that we would have x is equal to 2. And, of course, for a 45-degree reference angle, we're looking at root 2 over 2 for cosine. And because we're in quadrant 4, we'll use our all students take calculus, and we know in quadrant 4 that cosine is positive, so we will leave that positive. So just think of this as over 1, the 2's will cancel, and for the x coordinate, I'm getting square root of 2. And remember, you can get root 2 over 2 by knowing your points on the unit circle, or you could draw your 45-45 triangle. So 45, 45. And 1 square root of 2, and then use that along with your SOHCAHTOA. And we know that cosine, if I use this as my reference angle, is going to be adjacent over the hypotenuse. So we get 1 over root 2, and then rationalizing that by multiplying top by bottom by root 2 over 2, we get root 2 over 2. All right, moving along to the y coordinate, I'm going to have y is equal to 2. This time we're looking at sine of negative pi fourths. Again, making note that the reference angle is 45 degrees and that we are in quadrant 4. I'm going to say I've got y is equal to 2 times. Now, if we're looking at sine, we're going to use the opposite over hypotenuse. So opposite would be 1. And hypotenuse would be square root of 2, so it's still, we're going to get 1 over root 2. But again, rationalizing that by multiplying top and bottom by root 2, we get root 2 over 2. And again, using our all students take calculus, we notice in quadrant 4, sine would actually be negative. So I'm going to go ahead and cancel my 2's here, again thinking of that as over 1. And we're getting negative square root of 2 for the y coordinate. So we're getting for our xy coordinate, we're getting root 2 for x, and we're getting negative root 2 for y.